Stretching and compressing, you have to be very careful, don't you? You have to be very careful. So does anybody have one they'd like us to talk about? 6? 6? 6 and 7? Is that a good one to do? I think it's a good one to do. Okay, so here's your base function. This is your base function, and you're taking your base function, you're turning it into 6. What's one thing you know it has to do? Bless you. Yeah, you could both said the same. That's fine. Those are the two things. Shift which way? Shift right 2, and then so if we shift right 2, if this is f of x, if we shift right 2, it's going to be f of x what? Minus 2. And then if you stretch vertically by a factor of what? How do you know it's a factor of 2? It doubles. It goes from 1.5 to 3, so therefore it's going to be 2 times f of x. So, and then if I'll layer it on, that's fine, minus 2. So if you write this out, it's going to be y equals 3 times, y equals 2 times the square root of 3 times what? X minus 2 minus x minus 2 squared. Yeah. How could you verify this if you really wanted to be a little bit more sure about it? What could you do? Because if you just move it over 3, you're going to end up with something like 2. You're going to end up with that. But then if you double the height, it turns into the pink. Yeah, exactly. Exactly. How could you verify this if you really wanted to? What could you do to verify this? You could plug in points, but that's not going to verify the general shape. You could use your... Yeah, you could use your calculator if you really want to. Let's actually use that and see what it looks like. So if we use our calculator, the question is, does this match what we wanted? Does this match what we wanted? Does this look like what it's supposed to look like? It almost does. There's something missing, though. What does it look like it's missing? It looks like it's missing that little gap right there, right? Is that gap actually a gap? No. If you zoom in, what are you going to see? You'll actually see it. Why isn't it drawing it in? The resolution isn't high enough to graph that steep of a line, that steep of a curve. So if you zoom in, you will see it. This is okay. So it does match. And if you how could you verify it's at the right height? What could you use? What function could you use? Second calc, which one would you use? Maximum, right? Maximum. Enter. And again, this is still an estimate, but it's the calculator's estimate, so it's better than yours. And it's 3 right there. Y is 3. So does that match? Is that good? Yeah, absolutely. So what about the second one, though? This one you have to be very careful about. There's a couple of different ways to do it. What's one thing you know? Did the shape change? Did it get stretched or compressed? No. So this thing is just moved, and it's what? It's moved and it's flipped. So what's the first move you need to do? If you're just going to do a move and a flip, what is it? Here's the original, everybody. Move it 4 which way? Yep. 4 left. So it's going to be f of x plus 4, and then it's going to be, then what? But there's a gap here. Let's do all the moving first. Let's do all the... Well, actually, you know what? Do you want to do the moving first, or do you want to translate it first? Which one do you want to do? Do you want to flip it now, or do you want to wait and flip it? No, wait. Let's wait and flip it and see what happens. Let's go up how much? 1. So if we go up 1, what is it? F of x plus 4 plus 1. And now we're going to do what? Flip over the what axis? X-axis. So if we flip it over the x-axis, it's going to be negative f of x plus 4 plus 1. Let's see if this works. Can we see if it works? No, it moves 4, because look, it's at 0 right here, and then look where it is, negative 4. 0 to negative moves 4. So we can actually do this out interesting way. Flip first, yay, all right. You did A, B, and C okay? Yeah. So for D, what does the negative 1 have to, and do you do it before or after you move it up 3? And then what do you do? It flips it, it squashes it, and it Flips it. So what happens to the y values? Well, here's our initial y value, and then here's our y new. So let's plot some points. What's this point right there? That's negative what? Negative 4 comma 0. What's this point right here? 0 comma what? 4. And what's this one? 2, 2, 1. And what's the next one right there? What's that going to be? 4, 2. 4, 2. So this means multiply the y value by negative a half and then add 3. So what's the new y value going to be right there? What? Multiply by negative 1/2 and then add 3. What do you get? 5. 2 plus 3 is 5. Half of that plus 3 is? Negative half of that plus 3 is? What's negative 1 plus 3 is? 2. Negative half, negative 2 plus 3 is? 1. So what points are we now going to plot? Negative 4, 5. So where's negative 4, 5? Negative 4, 5 is here. 0, 3. Right there. 2, 2. And what? Something seems wrong. What seems wrong? It's pretty much a, what is it now? Does that make any sense? No. Not really. No. Something seems to be wrong here. Let's pause. See if we can figure out what we did wrong. Here, ready? Everybody clap. Yay! He solved it! So yeah, manipulate the y values. Yeah. That might be important. You're so good at this. So let's try this again. So it was... That's right. Yeah, nice. So negative a half plus 3 is going to be 3. Negative a half plus 3 is going to be 1. Negative a half plus 3 is going to be 2.5. And negative a half plus 3 is going to be 2. Negative a half of that is negative 1. Negative 1 plus 3 is 2. So let's try this now. Negative 4, 3. Okay, I'm liking that. 0, 1. Okay, I'm okay there. 1, 2.5. That's even better. And what's the last one? 2, 2. Does that actually look like it's supposed to be what it is? Yeah. So what's our new graph look like? There it is.
That one is 3.
What?
The one on the right.
Oh, 2, 2. Thank you. Yeah, 2, 2. Thank you. Right there? Thank you. On fire! Good. Does that seem pretty good? Oh, we missed a point. Oh, no. It's 4. No. Why are you letting me do that? We're supposed to plot, so it's negative 4, 3, 0, 1, 2. Thank you. It's 2, 2.5. I got to fix both of them. 2, 2.5 right there. And then 4, 2 right here. So, there it is. Cool? Okay. Any other things from the homework? Anything else? So, finding the domain when you combine functions. Let f and g be functions. A is the domain of f and b is the domain of g. If you put two functions together, if you add them together, the new domain is going to be the intersection of their original domains. Why? Why is the new domain going to be the intersection of their original domains? If you put two functions together into a new function, why is the intersection of their original domains the new domain? Yeah, your inputs have to be able to go into both because both now make up the new function. Exactly. So for the first three, it's pretty straightforward. If you add, subtract, or multiply, the domain is just going to be the intersection. What's the only thing that changes when you do division? What's the only thing that changes? We'll read what it says here. What's the one thing that gets added in? What's the one thing that gets added in? Which can't be 0? The denominator. Why can't the denominator be 0? We're not supposed to divide by 0. Exactly. Is it okay? Is a function allowed to be 0? Sure. But if that function is now a denominator, can it be 0? No. No, it can't. It can't. So what does that mean? Let's say you had a function, and let's do domain right over here. So let's say you had the function f of x, and the domain was from 0 to 5, as this. And let's say you had g of x, and the domain was -3, x less than or equal to 4. What's the domain of f of x plus g of x? Can someone tell me what the domain of f of x plus g of x is? Anybody? Any thoughts? It's the intersection of those two. The intersection. The intersection where they both exist. 0. Yeah, okay, so 0 and 4. What do we, x, and what do we put here and here? Less than or equal to, and? Yeah. That's where they overlap. That's where the intersection of the domain occurs. So that's the domain of this. So what's the domain of this? Same. What's the domain of this? Like g of x times f of x. Same thing. Now what about this, though? And it'll be hard to, we can't really do this right now, but again, what's the only thing you need to watch out for if you're dividing? Don't let g of x equal 0. To find out where g of x equals 0, we need to have a function for g of x. We need to have an actual function. So let's play around with this a bit. Hold on. So find the actual functions and then find the domain of each. So let's talk about the fun ones. Let's do fg. What does that function look like? Well, it's literally just the square root of x times. What's the domain going to be? Oh, thank you, just x squared, yep. What's the domain going to be? What's the domain? What do you have to do first? If you're going to find the domain of two functions put together, what do you need to do first? Yeah, so what's the domain of f? I'm correct. Can you speak so that humans can hear you, kids? Or one of you raise your hand so I can call on you. Yep, that's correct. What about g? What's the domain of g? X such that what? Part of that, it is less than or equal to 2, but it could be less than 0. -2, exactly. So if you have two of them, you need the intersection of those sets. So can someone tell me what the domain of this function is? Yes, Jonathan.
Larger or equal to 0.
Yep.
Smaller or equal to 2.
Yep. There you go. There it is. That's the intersection of the two domains. That's correct. So that's the domain for adding them and subtracting them and multiplying them. What about dividing? F over g is going to be the square root of x over the square root of 4 minus x squared. So that's going to be our original domain here, but what do we have to take away? Anything that makes this 0, right? What number makes that 0?
0.
No, you can plug in 0. 0 is fine. 2, so what do you have to change that into? There you go. Less than. Strictly less than. Because if it was equal to 2, what happens? The denominator is 0, and you don't like that, do you? Okay, that's good. What about a picture like this? What does this help us do? Something. It looks really complicated. It's really not. Take a look. Here's the function g of x. Here's the function f of x, those two functions. If you add them together, are you adding together the x values or the y values? The y values. If you add two functions together, you're adding together the y values. So if you add them together, you end up with this red, purplish curve. It's similar in shape to this, but it's a little steeper. Can you tell me why it's a little steeper? Yes. GS is not flat, exactly. Since GX is increasing, are you adding the same amount to each point? No, you're adding, as G goes on, you're adding more and more. You're adding more and more. So what does that mean? In terms of labeling, this point right there, that would be, the height would be f of a. What's the point right here? G of a. And what's this point? What's that third point right there? G of a plus f of a. And can you tell me, what is this distance right here? So what's it come out to be? F of a. If you add two things together, it's going to be the upper one, right? So that's just graphically what it looks like. Graphically what it looks like. So, yeah. So look, we have our half arc, 4 minus x squared, and we also have the square root of x right there. What happens when you add them together? The domain is the intersection of their domains, correct? What's the domain of this yellow? Well, we know it's x is greater than or equal to. And what's the domain here? X less than or equal to 2, and it's less than or equal to negative 2. So if you add these two functions together, you end up with this function. But where does that function have to stop? It has to stop at, and it has to stop at 0, because this function can't be less than 0, right? And this function right here can't be greater than 2. So what's the new domain here? The domain here is going to be greater than or equal to, and less than or equal to, or less than, because you can't be 0, you're dividing. Oh no, with adding, I'm sorry, adding. What can it be actually? I'm sorry. What can it be? Can it be equal to 2? Yeah, because can the function equal 0? Sure. Can you divide by 0? No. So graphically, that's another way to think about domain. Another way to think about domain. You might not find it interesting, but I find it interesting. So again, all of these things, these are all the same. It's the same way of writing function composition. Can you have more than 2 functions? Absolutely. You absolutely can. You can graph it many different ways. Okay, so let's try some practice problems. Please try these. Please try these. Be clear and concise. If you're not sure, just take a guess and see if it works. What do you think? So could someone tell me on what's f composed of g on this one? Can someone tell me, raise their hand and tell me what it is? I'll get you started. This is f of g of x. So can someone tell me what it is? Raise your hand. Yeah. It's going to be what? X minus 3 what? Yep, that's correct. What about g of f? That's going to be g of f of x. Can someone raise their hand and tell me what that is?
Wait, will you explain the first one?
What is f of x?
X squared.
Something squared. And what are you plugging into it?
Oh, that's simple.
And what is it? Bingo! Yay! Ah. So on this one, what's g? It's going to be g minus, so it's going to be f of x minus 3, so what's it going to be? All done.
Can we do this for the rest of the semester?
Now, can you plug f into itself?
Sure.
Absolutely. G into itself? Sure. Absolutely. So please do 8 and make sure you come up with the proper domain for each. Okay, so A. So we have f composed of g, which is f of g of x, which is the square root of g of x, right? The square root of g of x, which is going to be the square root of, yep. Man, it doesn't really change much. The domain-wise, though, we have to be careful about this. What's the domain of that function? What is the domain of that function? Okay, so what do we know? Let's look at the inner function right here. The radicand underneath the radical has to be what? So 2 minus x has to be greater than or equal to 0. So negative x has to be greater than or equal to. So x has to be less than or equal to 2. Does anything change with the second square root? No. If you can square root something, can you square root it again? Yes. So what's the domain of this function? Yep. There it is. Yay. Do you wanna? Which one do you want to do next? C or F? C or D? D? Let's do D. So that g of x is going to be g composed of g of x, So what's that going to be? The square root of 2 minus, like that, right? So first of all, if you can't plug it in there, can you plug it into the big function? Essentially, if this is imaginary, can this be real? No. So first of all, we know that 2 minus x has to be greater than or equal to 0. Another way to think about that, too, is we also know that 2 minus the square root of 2 minus x has to be greater than or equal to 0. So what does that tell us? We have to be really careful about this. We have to be really careful. 2 minus the square root of 2 minus x has to be greater than or equal to 0. So that means 2 has to be greater than or equal to 2 minus x. Let's just write that like this. 2 minus x has to be less than or equal to 2. What should we do to both sides? So we know that 2 minus x has to be less than or equal to. So negative x has to be less than or equal to. So x needs to be greater than or equal to. X needs to be greater than or equal to negative 2. Let's see if that makes sense. If it's negative 2, what does this thing equal? If x is negative 2, 2 minus negative 2 is? The principal root. The positive root of 4 is? So that's equal. That's correct. Right. Well, what happens if it's... What's the integer that's closest but greater than negative 2? Negative 1. Congratulations. What's 2 minus negative 1? 3. We're doing basic math here. I'm not asking you for tricky stuff. What's the square root of 3? Is that less than 2? Sure. Can we make this arbitrarily big, though? That's what we have to watch out for. X is greater than that. Could it be 0? Sure. 2 minus 0, that's less than or equal to 2. Let's do this. Oh, I erased something here. Sorry. Could this... Well, x is greater than negative 2, so is 10 a possible answer to this statement? Yeah, but can you plug 10 into this? No. Okay, so because of this right here, because of that right there, what do we know? We know that x has to be greater than or equal to negative 2, correct? But also we know that 2 minus x has to be greater than or equal to 0. That's what's underneath the square root sign, right? That's what's underneath this one right here. So we know that this has to be true, and that has to be true. What does that tell you? Negative x is, well, actually, 2 greater than or equal to x, so x is less than or equal to 2. So both of these have to be true. If both of those have to be true, what's the domain going to be? X is greater than or equal to, and less than or equal to 2. They're different words. So there's your domain of the new one. Domain equals tricky. You have to be very careful. Always check reality. Always check it. Always check it. Okay, let's pause this for a sec.